Okay, students, today we have a new formula, and for this one, if we have this term, then FB, then this sigma equals FB minus F of A minus 1. Now this may sound complicated, but let's just like expand it, okay? We know from previous lessons about indexing that when we have something like this, okay, when we have these indexes, this one, this one, and this one, when we have this one is one step after this one, we can just do like this, and we will be left with r equals 1b, okay? But when do we use this? When do we use this formula, this one? When do we use it, and why? Okay, so if you notice, this formula's main function is just one thing, and is just changing the r into 1. Now, why is that? Simply because we want to apply the formulas I mentioned before, the summation bank, okay? The ones that were here, I think. Where were they? Okay, just one. The formula bank. Wait 1 second. Okay, so this was the formula bank, okay? And if you notice, every single thing in it, okay, we have r equals 1 here, r equals 1, r equals 1, r equals 1, okay? And look, we don't care about n here, because we can like let's say if instead of n here, we had let's say 6n, we simply just remove every single n and we put 6n. But like if we have like something like 2 to the power of n squared minus 1, we can simply just put 2 to the power of n squared minus 1, like that easy, okay? So we don't care about the thing here, we only care that the r shall be 1. This is why we need to use this formula for ugly r's, for r's that are not ones, okay? So let's see some examples. Students, we have this example, okay? This is the main rule that we will use, and let's see how can we use it here. Okay, so we have sigma r equals 100, 200, r. Now we wanna transform this into r equals 1, like r equal ones, okay? So it's basically this is the equivalent of sigma r equals 1 b, which is here 200, r minus the sigma of I equals 1 a minus 1, which is here 99 r, okay? Yeah, so back to the formula bank. So for this r, so here we have the exact same shape as this one, okay? But instead of n we have 200, so we just substitute 200 in the place of n. So it's equal to n and plus, okay, n here is 200, so it's basically equal to 200 times 201 over 2 minus, here n is 99, so it's 99 times 100 over 2, and as simple as that. Okay guys, so here the integers from n to n squared inclusive, meaning that the sigma, and we want to find their sum in fully factorized form, meaning that we want to find sigma of r of n squared r equals n squared r, which we basically we just use the rule that I told you, this one. We shall keep it in front of us so we can see what's going on. Okay, this is it. Okay, so of n squared r equals 1 r minus sigma of a minus 1, meaning that n minus 1 r equals 1 of r. So for this one we'll use the formula bank, we'll use this one, of course, okay? So it's n times n plus 1, but n here is n squared, so it's n squared plus 1 over 2 minus, we will also use the same one, but instead of n, obviously, we'll put n minus 1. So it's n minus 1 times n minus 1 plus 1, which is basically n over 2, and that's it. We can like factorize it more. Like if we put the if we expand this and we put them on the on 1 2, we'll get n to the power 4 plus n over 2, which is basically, you can take n as a common factor, so it's n plus 1, n cubed plus 1 over 2. Okay, students, we have another example, and obviously since r isn't a 1 here, we do want to standardize it into 1. So we want to apply this rule first, then one of these one. Sigma 3n r equals sigma of 3n r equals n plus 1 r cubed equals the sigma of r equals 1 3n r cubed minus the sigma of r equals 1 a minus 1, which is here, n plus 1 minus 1, which is here which is n basically, r cubed. Now the first one, we want to take this rule, this one, okay, from the formula bank, and we will apply it. So it's n plus 1, but n here is 3n, so 3n plus 1 over 2 squared minus, we will also use this rule, okay, but here n is n, okay, so minus n plus 1 over 2 all squared. Now you may stumble upon like a question like this, okay, and it's basically like a very small and easy trick, okay. So what we're gonna do is that we will expand this term and we will just distribute the sigma as always, and it's solved now. So it's basically r cubed plus r squared, so it's basically the sigma of r cubed plus r squared, therefore it's sigma of r cubed plus sigma of r squared, which we have their formula and we just like insert it here, and that's it.